graduate store yang kita mau rancang the whole year, all the year sampai Desember. Mungkin ada beberapa sesi lagi nanti di Politecnico di Milan. Dan kita mengundang khusus profesor yang buat saya sudah proven ya. Anda bisa cek publikasinya ya di jurnal-jurnal yang saya anggap nggak friendly ya, karena memang susah jurnal-jurnalnya ya. Dan saya ingin mereka sharing tentang metodologi, khususnya di FSRD, mungkin di arsitektur juga banyak juga yang mungkin beratnya titiknya ke apa ya, interpretatif gitu ya, which is fine, cuma kita perkaya dengan yang sifatnya empirical atau dengan basis eksperimental. Nah, jadi bukan maksudnya mau membawa ke positivistik, enggak sama sekali. Semuanya sama-sama penting kan. Cuma kita melihat trennya kan banyak gitu. Jadi kita coba perkaya pengalaman kita. Nah, Prof Georgi ini nanti detailnya di-share sama Pak RW utama Pak Zen, Pak Doni ya. Nah, akan share lebih detail. Tapi beliau ini, kalau saya dulu lulusan Jepang, lulusan JAIST. Nah, Pak Georgi ini senpai, jadi senior saya. Dia ngajarin saya dulu network analysis. Kalau beberapa udah saya ajarin associative concept network analysis yang tidak dipakai lagi sama beliau. Dan dia ngajarin saya. Sekarang dia udah advance, sudah pakai macam-macam alat. Dan sebelumnya beliau profesor di Ubiquitous Center ya, di Oulu, Finlandia, yang sekarang lagi summernya cuma 2 minggu, dinginnya paling panas jadi 15 derajat nih sekarang nih, sehingga dia problem nih sekarang nih, karena kan kita sekarang berapa mungkinnya, udah 20 something gitu ya, jadi atur. Nah, beliau nanti akan cerita beberapa pengalaman dia, termasuk ada mahasiswa S3-nya dari Indonesia juga ya, yang sudah publish di jurnal top juga, virtual reality. Oke, nah belum lagunya nanti sebentar. Jadi tolong dilihat bagaimana beliau dan mahasiswanya itu selalu terbuka terhadap berbagai metode-metode yang mereka rancang sendiri gitu, mereka kembangkan sendiri, menggabungkan dengan alat-alat lain. Dan menurut saya itu menarik, walaupun kita belum banyak punya fasilitas itu, tapi kita menuju ke sana gitu ya, supaya merata, nggak menjadi semuanya yang sifatnya berat di kualitatifnya, gitu ya, kurang lebih. Dan sepulang dari ini Georgi akan ulang tahun, beda seminggu sama saya, bulan Juni, kita Gemini ya, Gemini Box. Oke. Joni nggak ya? Oh sama. Oke. 5 lagu kalau gitu. Oke, kita mulai ya, silakan Mas Joni, please in finish ya.
Thank you so much Pak Denny, and very good morning to everyone. Selamat pagi semuanya. Welcome to Grad Talk Series 2. I'm Johnny, a doctoral student here, and Grad Talk Series 2 Art and Design Research Methodology, hosted by Doctoral Program in Art and Design Sciences (FSRD). Hosted by the Doctoral Program in Art and Design faculty (FSRD ITB). For those joining us for the first time, Grad Talk is our flagship doctoral seminar series where we bring leading scholars from around the world, not only to share what they research, but more importantly, how they think. Allow me to introduce our distinguished speaker, Prof. Georgi V. Georgiev, is Professor in Human AI Creative Collaboration, Neurocognition of Design Creativity, and Digital Fabrication-Enhanced Learning. He leads the BRAINtoBUILD laboratory, the laboratory on digital empowerment and creative materialization at the Japan Advanced Institute of Science and Technology, or JAIST. Before JAIST, Prof. Georgiev was Professor of Design Creativity at the Center of Ubiquitous Computing, University of Oulu, Finland, bridging two of the most rigorous research environment in the world. And Prof. Georgiev serves as Deputy Editor-in-Chief of the International Journal of Design Creativity and Innovation as a Q1 journal published by Ted and Francis and sits on the editorial board of the Journal of Engineering Design. He is a founding member of the IJDCI Creativity at the Design Society and scientific committee member at ICED, IASDR, Design DRS, and Creativity and Cognition ACM. His academic journey itself reflects deep interdisciplinarity, a PhD knowledge science from JAIST, and 2 master degrees from the Technical University of Sofia, Bulgaria. Today's session title is how to research design and creativity, methodological foundation. But what makes this lecture extraordinary, it's scope, guys. And Prof. Georgiev will walk us through 5 interconnected research streams that span from the human brains through EEG and fNIRS measurement of creative cognition. We will have approximately 75 minutes of presentation, followed by an open question and answer. For your question, you can scan the QR code there already on your desk, or simply typing bit.ly/askprofgg, or simply raise your hand when the time has come. Without further delay, please join me in welcoming Prof. Georgiev. Professor, the floor is yours. Let's give a big round of applause.
And once again, we have preparing some refreshment outside. So please feel free, enjoy bring the foods inside and follow the talk. Thank you.
Thank you very much for the introduction. And I would like to thank Professor Georgi for the invitation. And this has been an amazing couple of days here, and looking forward to also other events in the following days. This is amazing university. I think this is quite nice atmosphere, academic atmosphere here. Yes, but now I'm in Finnish summer, 20 degrees. Just finished summer after 10 years in Finland. I'm getting too much used to this 20 degrees. So, and minus 20 in the winter. Well, once again, thank you very much for this invitation, and it has been absolutely an honor to me to be here. And today I will try to cover a range of research examples. I will, because this is focused on methodology, I will not go to so much into results, more like how to address such kind of challenges methodologically. It might be a little bit overwhelming because probably we have 40 plus examples here, well, I'll try to keep it focused on the methodology. Most of the slides have research examples, and when there is a citation on the bottom, that means the research is published, and some of this research is not yet published, it's under review, and in this case I don't have the citation, but I was hoping sharing research under review will be also beneficial, because there are some different methodological approaches there. And well, it's not working. Okay. Okay, it's not working. Okay. Yes. Yes. Okay. Now it's strong. Okay. So for 10 years until 2 months ago, I was with the University of Oulu, Center for Ubiquitous Computing. This is summer picture of Oulu. You don't want to see the winter picture of Oulu. It's white. And this is fairly large university. And I was at the UBCOM, Center for Ubiquitous Computing, which is the largest HCI group in Finland, with approximately 85 people. I was leading one of the groups there, one of the 4 groups there, focused on design creativity. Well, this is the university. This is all interconnected from north to south. This is 1.1 kilometer corridor for Finnish winter. So this group was a little bit more focused on understanding of empowering human capabilities and behavioral characteristics to design creatively. But during the course of these years, the research a little bit broadened, and now in the new place, it's a little bit more overreaching to do between different fields. So one important thing is the research which I mentioned today is mostly done in Oulu, but some of the papers now are finalized when I'm in JAIST. This is my group in Oulu. Still, we have a postdoc and still 4 doctoral researchers. This will continue for maybe up to 2 years from now, because the doctoral researchers have to graduate. Probably first on the line is Umi Latif. Obviously she is from Indonesia, and she has been done quite amazing job in her thesis on rehabilitation, but more on this later in the slides. Okay, so probably the most important thing is all this research is not single person research. This is collective effort, and quite often more than 2 people are involved in this research. that means more than one doctoral researcher, and sometimes master's students, sometimes even bachelor students are involved in this research. So certainly this is collaboration effort towards these publications. Oops. Okay, let's leave it slow. Okay, so 2 months ago I moved to JAIST, back to JAIST. This is Japan Advanced Institute of Science and Technology. This is the university I got PhD 17 years ago. In between that PhD, I have worked in Kobe University and then in University of Oulu, Finland for 10 years. My new laboratory in JAIST, I wanted to be a little bit broader, more interdisciplinary, but also highlighting the process from brain to build. And this is referring to ideas. My lab is on the 7th floor there, in the first building of neuroscience, of JAIST. And this is a little bit more focused on research. From initial enrollment, master students there are doing research. And this is graduate-only university. That means there are only masters and PhD students there. So where is JAIST? It is on the opposite side of western coast of Japan, roughly the same level as Tokyo, but we are divided by 2 mountain ranges. The only way to reach it is by plane for 1 hour or 2.5 hours by Shinkansen. Okay, so the BRAINtoBUILD laboratory in JAIST is trying to view the things a little bit more overreaching. We are focusing also on human AI interaction towards innovation, and we are trying to follow this maybe pipeline, but it's not single, from how the ideas are generated in human brain to initial implementation in real world or materialization of these ideas, and everything on the way between the two. That covers various aspects, and certainly we very much look into AI developments that support this process or support understanding of this process. Okay, so basically we are having these 5 areas, and the following slides will try to follow a number of research examples per each area, but in reality there is a lot of interconnections. I will try to point these interconnection points, because some of the results of one of these areas we are covering are feeding methodologically often the way the research is approached in the other areas. And certainly these overlaps are kind of minimal compared to the real interconnection of the things there. So I will start from human AI creative collaboration topic, and then we'll go clockwise. Some of these are more or natural science side. For example, this is more like natural science. Some of them are more social science side. Some of them are more education, but we'll see. Okay, so let me press it. Yeah, thank you. Okay, so this is the plot from Saibal of the research from our laboratory, and you can see at the moment it's natural science and engineering in the colder colors are a little bit more than half compared to the arts and humanities or neuroscience or social sciences or psychology. But we're covering all these fields, and this is the plot from Saibal with the major topics. So the size of this circle there is showing the number of publications. So we can see that we are highly interdisciplinary, because this goes from social sciences to computing or even medical sciences. And if we see the major topics, the 5 major circles there, they are in the automatically generated categories, by the way, in Saibal. Makerspaces as catalyst for educational innovation, creativity and inspiration in multicultural contexts, empathy, development and social implications, interdisciplinary approaches in design innovation, and the last one is stroke rehabilitation technology. So you can see that this is fairly large range of topics, and this is just brief, maybe it's too much detail here. These are the actual subjects. But what is important here, I would like to point, is that this is the field-weighted citation impacts of these publications, and some of these are 4 times the average of the particular field. Some of them are less than 1, but some of them are very influential, like 3, 4 times the average citations. So, we heard this from the introduction from Denny, but I'm also Deputy Editor-in-Chief of Design Creativity and Innovation, which actually is helpful because there is a lot of learning with the overall process of publishing successfully. And what is the unique here, I'm 14 years with this journal since the inception, and the initial efforts of the building the journal, I had a major contribution there. And okay, Okay, let me go to the 5 fields. The first example, group of studies we have done is on the human AI creative collaboration, and I can try to give some examples. This is very simple initial example where we are using off-the-shelf method, in this case 635, very well-known method for idea generation, but we are augmenting this with generative AI, and we found here, for example, that this influences the number of the ideas, for example, or which idea is best. Is it derived from AI or from the collaborators in the team? This is teamwork focused method. So this is very simple example how to utilize generative AI in such kind of studies. I'll give more elaborate examples later slides. Another methodological example here. This is summary of student projects in a class at the end of the class, which were tasked with using generative AI to explore creativity. And this is the thematic analysis of their projects. And here we can see that they have not only tackled not only common topics when we use generative AI, such as seriousness of future or some technical aspects, but students have been quite sometimes quite unserious with their projects. You can see them serious entertainment or so. So this is example of totally qualitative oriented research. So this is summary of 40 projects of students, individual projects, and this is how they were analyzed. So this is actually, oh, this is not correct. This was published in Computers in Human Behavior, Artificial Humans. Yes. Okay, so unpublished research, there is no reference, but this is master thesis which is submitted today, actually, should be submitted. Okay, so first of all, this is connected with one of the later research topics, and I will point back to this connection, but basically, this master thesis was trying to create a system that generates visual and semantic visual and text stimuli with certain characteristics to be used in design experiments. So this is the only purpose of the work is to create setup for bigger work. So methodologically speaking, and what is important is particularly this setup. In the later experiment, we are trying to see the differences of abstract and concrete thinking on design education context. And this system is capable of controlling the stimuli which is generated for the later experimentation, both textual and visual. So we can see these are abstract images on particular task, which are used as stimuli in design experimentation, and these are more concrete stimuli used in design experimentation. Okay. Okay, so obviously the premise was entirely implemented with particular to AI tools, and this is even more elaborate use of generative AI tools in design education. This is totally different approach. We have a prototyping course, which is focused on relatively fast-paced, from idea to initial prototype, 7 weeks, of teams of 4 students. And what they do is they prototype in digital fabrication environment in FabLab, but they have to document their process, and because the class is very big, the challenge for teachers is to provide timely feedback to their progress. At certain time points, 2 or 3 teachers have to provide feedback to 30 teams. And everybody has very different ideas, implementation and so on. We have created a dedicated documentation system. Each week there are different requirements to satisfy. This system is actually a very elaborate system, that neurosymbolic feedback system, which is trying to replicate the expertise of the instructor. This is based on the interviews with instructors, and this system is capable to provide certainly, to a certain degree, feedback to students in a matter of seconds after their documentation. It's multimodal. It can use text, images, and video from the documentation, and provides overall assessment of the particular input from students. And actually, this uses 3 different models: ChatGPT, Cloud, and Grok, and combines the outputs of 3 in matter of. Typically, the feedback is delivered in a matter of less than 30 seconds. For teachers, it will take much more time to provide feedback. This is certainly not resolving design education feedback, but it's helpful to receive quick feedback in the beginning. And we found this is very helpful in the case of very different ideas the students have, because this might vary a lot. I don't know if you can guess the purpose of this prototype in the image, but this is actually card sorting machine. It puts 3 cards on one person, 3 cards on another, 3 cards on. So this is the example of complexity of the prototypes they have in this course. Okay, so these are a few examples from the first category. Maybe we can go to the next. So here we are trying to focus on more on design creativity side, but also we tackle various aspects, in this case also empathy. And we are using technology to understand and enhance or prompt empathy for this kind of early stages of design. That means this is a stage of ideation towards particular design task or design problem or user group. Okay, so a few examples. This is a very early example. This was published in EBD conference 23, but this is using video, which is actually generated from VR environment, just video shown on such kind of screen in a class, and the experiment was in a class. And this is trying to tackle individualism and collectivism, which is type of cultural difference which is well known to influence creativity outcomes. And actually this study pointed that it is possible for short time to influence individualism, collectivism aspects towards higher design creativity. And here we had the results that collectivism group was performing better, but also there were, individualism group was performing better, and, but there were also kind of side effects. Some of the ideas were more towards personal use, and some of the ideas were more towards public use. This is examples of the task of transportation in mountain area. So this is methodologically, this is example of very simple experiment done in class, 3 different class sessions, and we have different influence in each session. For example, collectivism versus individualism. So, okay, so this is further, this idea expanded into VR study. This is based on 10 minutes VR experience, experimental study, which is tackling another well-known cultural difference, uncertainty avoidance. So that means if somebody is avoiding uncertainty, likely is less creative because the solutions might be less novel, for example. And this study, by the way, published by a very good journal, Computers in Human Behavior, factor 8 something. We had this VR experimental study where we initially classified our participants into high and low uncertainty avoidance groups, and then we tried to influence them in the opposite direction. And actually, this is low uncertainty avoidance group is very successful, somehow successful in the other high uncertainty avoidance group. And this actually very successfully influenced creativity and pointed out that there is an optimal place where two opposite conditions which are undesirable are addressed successfully. This is workability, uncertainty avoidance, novelty. So we have the case where workability is very low, very high novelty, very low uncertainty avoidance, but then the opposite is very workable, high uncertainty avoidance, but very low novelty. And we have optimal case which is addressing the two issues. So this is an example how 10 minutes VR experience, not very interactive story, it's just the person is immersed in the virtual reality environment and seeing two characters communicating there. But this actually successfully tackles uncertainty avoidance. Okay, so this is one of the oldest studies. And actually this one is the root of the one where I mentioned abstract and concrete stimuli in the previous group. Based on dataset, well-known dataset from 2013, we have conducted computational study. The well-known dataset is based on the real design education in US University. And we have analyzed this with semantic networks. So basically they are trying to quantify what is changing in the conversations between the teacher and students. Typically individual feedback, but sometimes also peer feedback. And we have found that certain parameters of these networks are influencing the creativity of the outcomes. And the study which I mentioned previously actually is trying to alter abstraction, which is one of the probably easiest to tackle. So this is a kind of computational one, but the results of this are entirely real-world data study. We have found certain characteristics of pertaining to the communication between the teacher and student, and we try to replicate this in experimental studies later by creating dedicated stimuli based on one of these parameters. And without going to details, but these are the various parameters, and the abstraction, the red one, we are trying to tackle in some of the later studies. These are these parameters of the semantic networks over time of a set of conversations. And we found that these have different effect on creativity and successfulness of the ideas in this design education. Okay, so a little bit jump here. But this, from this and following slides, I'm trying to address the aspect of empathy. And some of these ideas are brought from other studies, but here one of the main premises here is to use digital technology, in this case virtual reality, to gain empathy towards particular user cases. In our studies, more often this is rehabilitation cases, but sometimes it's very peculiar user group. This is the earliest study from 2019, where we were trying to simulate physically after stroke rehabilitation condition for non-affected users. And then the premise is this is influencing the ideation towards ideation for this kind of users. So this is conference, but later on we have a range of studies in that direction. This is color vision deficiency. By the way, this study won Best Young Members Presentation Award in a large conference. This is the flagship conference of the Design Society. But here, for non-affected users, we are trying to simulate the struggles of color vision deficiency. And we found that the complexity of the environment is influencing the understanding of the case, and then this also leads to better ideation towards the condition, how to facilitate the daily life in this case. So here, again, fairly simple study, 15 minutes between subjects. Non-affected users experience the color vision deficiency in the virtual environment, and then they ask to ideate after the experiment. Okay, so on published study, on the review. So here we are trying to simulate memory loss. This is again done with the virtual reality experience. So basically the story is that the participant is engaged with gallery visit. They get off their car to an elevator, go to the gallery, and then they are back to their to the parking lot to find their car. We intentionally created a lot of confusion when they're going back, and they struggle through different floors, different places to find their car. And we found from this study, we are measuring their behavior in the virtual environment. We found that the backtracking and hesitation actually contribute to the empathy generation to memory loss condition. And this is totally measurable because we can measure it, what happens in the virtual reality very simply by tracking. These are examples of these routes taken on different floors of the parking lot. So you can see that again, targeted virtual reality experience can create particular situation which is leading to empathizing with a certain type of users. And again, on the review, it's a secret. This is even bigger study, 40 people, 2 conditions. We are trying to simulate essential tremors with dedicated device on the virtual reality controllers. And this is mixed method study, very trendy term with generative AI. Nowadays, mixed methods, but we are having fairly elaborate experimental sequence to simulate this common condition of essential tremors for non-affected users. And there are a set of 5 everyday tasks in the virtual reality environment. And we are investigating their empathy before and after with different scales, but also we have semi-structured interview, and then explanation of the design, rationale, problem definition, solution ideation, and at the end, mind mapping. So this is totally qualitative approach, but this is quantitative, including various parameters to be derived from the virtual reality experience. This actually proves that because we had 2 conditions, implicit instruction and explicit instruction towards empathy. They are both inducing empathy and also contextually grounded problem solving towards this kind of users. Okay, so we are now going to the rehabilitation, but you can see the connections. Before going to the research examples here, I would like to show that okay, they're not pointing, but
it's there.
Okay, sorry, now it's working. Okay, it was. Okay, so this effort is grounded in very big project we had from 2019 to 22 with 4 other universities in Europe, 3 rehabilitation centers, 5 companies, and it was focused on VR environments for rehabilitation. You can see that earlier study which I pointed 2019 actually is prior to this project. You can see that some of the studies actually contributed to the project, but then now you'll see that this project sparked other studies. So everything is interconnected in that sense. So this is a project on VR environment for rehabilitation, but it's not only the VR environment, it's creating also bespoke rehabilitation controllers for the upper arm, upper limb, and it's generating the categories of physiotherapy, automation, virtual reality, and additive manufacturing. this is what we were doing in the project in terms of mapping interactions, but also designing the electronics. Without going into much details, this is bespoke controller using off-the-shelf tracker, but this is rehabilitation-focused device here, which is changing the tension in the different directions, and it's totally electronically controllable. And this was experimented in the real hospitals. On the right side, after stroke patients, this is musculoskeletal injuries, typically younger people. So this sparked a number of related studies. And you can see the connections also with the VR studies early on. This is cumulative thesis, actually. We had a number of studies with regard to the kinematic assessment. In virtual reality, this is, for example, the typical therapeutic movements required there. And this is the final outcome of the thesis, which is actually independent VR rehabilitation toolkit that can be used with off-the-shelf VR equipment, with off-the-shelf games, as long as this is compatible with the therapeutic movements. And this is the panel for the therapist, which can be outputted in terms of various parameters of the movement. You can see the speed-related, smoothness, range of motion, speed, so peak velocities. There are a number of parameters that can be seen. And actually we found that some of these things are never, are new to the therapists and actually quite informative, because this cannot be easily observed by eye in the real world. Okay, so this is an example of the thesis, and this project now actually continues in the education project, still ongoing, focused on wearable devices for rehabilitation. This is with 2 other universities, and this is the summer activity novel we had last summer. Okay, so now it goes even more complex. This is more natural science. Neurocognition of Design Creativity. It is again about ideation, but we have certain methodological approaches here, which are actually I think original, but let me show. So, currently we're using EEG and FNIRS in several studies. We are conducting maybe 5th study at the moment. And unlike the typical experimental studies in design area, we are trying to replicate design education. And it's quite challenging, but what we are trying to see is 2 major paradigms here. One is stimulus, and what happens when the student reads the stimuli, when the student, in this case textual, but you saw that we have now experiment with visual also. What happens in human brain when the student reads the design task, and what happens during the designing. And the other paradigm, which is even more challenging, instructor and student. Actually, we don't have it in this illustration, but we have also attempt for inter-brain synchronization there. Okay, so this is idea generation, early stage of design before feedback of instructor, during feedback of instructor, and after. So we have several studies and some very interesting findings there. But before going to the studies, let me show another connection with the previous methods. We actually use the same premise of the abstraction and concretion for drafting stimulus with the help of generative AI. We create initial drafts based on expertise. Then with generative AI, we create versions. This is evaluated by human, and then we create different conditions. For example, abstract, baseline, concrete conditions, and we test this within subject experiment. And let me show some results. This is very simple basic study. What happens before and after feedback of instructor? Or somehow, not surprisingly, increased brain activity in the follow-up ideation. Again, sketching. So we have sketching, feedback from instructor, and then sketching. Obvious higher brain activation across several frequency bands and channels. So this is the power spectrum density of the human brain. This was published by conference. Okay, this is even more elaborate study with the stimulus which I showed 2 slides before. We have abstract baseline concrete stimuli within subject, but this is just semantic stimuli. They read stimuli, they have design task, they have designing, and we are comparing the brain activity. So we have the task, the brain activity, and the final creativity of the ideas generated. Might be the battery. Okay. Can you play the video? This is the right side of the video. Yes. Okay. So this is the difference between concrete and abstract thinking, and this actually shows that abstract thinking is leading to higher brain activation, and it's leading to higher novelty and higher surprise at the final ideas. So this is a kind of different study. We are using EEG data, which is gathered on the surface of the brain, but this is computational method for finding the sources within the brain with regard to this. So basically this is evidence that, well, every design educator will hypothesize this, that abstract thinking might be better for creativity than concrete one, but this is evidence what happens there. So here we are using the same experimental paradigm, but the computation is different because we are trying to see the sources within the brain. It's not on the surface of the brain. Okay, so let me see if it's okay. Okay, so another study. This is, oh, I don't have the reference here, but it's published 2 weeks ago. Again, the same experimental paradigm, ideation, instructor feedback, ideation again. What happens? We are trying to see functional connectivity within the brain before and after. This is done by face lock index. If we go to the next slide, okay, what this finds. We have the feedback from the instructor. The functional connectivity changes. Before instruction, there is widespread connectivity. After instruction, there is selective, more task-related connectivity, and this is more effective for design thinking. Very simple finding, but so basically, feedback from instructor focuses the thinking of the student. Yeah. Okay, so Okay, well, unpublished study. Actually, this is even before submission. We have the draft, but it's ready for submission. So this is comparing abstract versus concrete feedback based on EEG data. And on the left side are the higher activation, significantly higher activation for abstract. On the other is significantly higher activation for concrete thinking. And we have the novelty, surprise, general creativity, and usefulness. And we can see abstract is definitely leading to higher activation across several bands, and also leading to higher novelty, higher surprise, and higher general creativity. On the opposite, the concrete is kind of better for usefulness across frequency bands. Okay, so this was a kind of demanding, but maybe you can. Okay, the last topic, technology-enhanced learning. This is grounded in digital fabrication in FabLab context. And actually this is methodologically, I guess this is a good example because bridges design education, design research. In all, we have still have very large course, as mentioned. Typically 30 teams, 120 people doing prototypes on their own ideas. So very little restriction there. And we are using this course for various studies. Typically they're observational, but they might be a certain intervention introduced to the course, and then this is, we are trying to see how this influences the whole thing. And yeah, so, and this is actually pointing why BRAINtoBUILD, because we have very initial ideas from Brain we saw previously to actual initial working prototypes. Keep in mind, this is not design major. None of them has ever received any dedicated design training. They are computer science, but also other faculty. And typically mixed teams, and they're free to ideate and until they have functional prototype. They might look very ugly, but some of these are very sophisticated functionally. That means there is control software, something happening, something's measured, something reacting, and so on. And this is my example with using this course for very different studies. This is very same activity with 3 very different examples. For example, here, this is from study which is comparing creativity before and after. This is from study which is focused on design outcome. This is from study which is focused on teamwork, self-reported measures, and expert evaluation of the outcomes. And let me give you a number of examples. But before this, some more details about the course. It's very fast-paced because they have, in reality, exactly 6 weeks to make it work. Because the first week is obviously building the teams, the initial lectures and so on. They actually have only one 2-hour lecture about design. I don't think you can learn design from 2 hours. That's obvious. But they're making working things in 6 weeks later. So, and the beauty of this is very little restriction. The only requirements is to be done in the FabLab. It must have something physically moving and should be controlled by software, and it has to have one input and one output. That's the only restriction. As long as it is not crazy expensive, it's is possible to build there. So, okay, these are the standard machines we're using. It's no surprise if somebody is working in design education. Then he has solar from one. Now it's 50% bigger. They made it more machine. Okay, so maybe next one. Okay, very basic studies. This is in line with the documentation system which I mentioned. For example, this is a study a couple of years back. The initial implementation of the documentation system, but also keep in mind we had a summarizer used to know OpenAI, using OpenAI API, but also dedicated prototype capturing system for their projects, and they were asked to do capture the prototypes on a weekly basis. And this is an example of the earlier implementation of the documentation system, but there is guidelines that they provide various things. For example, this is the simulation of the electronic circuitry, sensor, actuators, and so on. And this is the actual prototyping video from their work. Okay, another very simple study published in a conference. We are in the same course. We are trying to see how their self-perception about skills, confidence, motivation might relate to grades, and there are certain collections there. Fairly simple study.
Not that simple.
If they answer the question, it is truthfully, which is challenging. Okay, so we have sustainability intervention in the course. That means in several different years we had increasing intervention with regard to sustainability. They are asked to consider various things with regard to sustainability. For example, to simulate the things in software instead of going directly to a prototype, or to consider disassembling the thing, or to consider iterations, change the materials with different iterations. And just examples, we implemented this sustainability framework with regard to the materials and processes. They are asked actually to report their material use and time on the machine, because this kind of creates self-awareness how much they have used as resources. And by the way, if they are unrestricted and they can make a new prototype every few days, this might be quite challenging in terms of sustainability. Okay, so another study, and again sustainability, in the second year of this intervention. And this is based on self-reported measures and expert evaluation at the end. So we are seeing teamwork quality, team member success, and team performance, along with sustainability values. All these are well-known questionnaires from the literature, but we compare to the sustainability grade at the end. And there are some very interesting connections in terms of teamwork quality that relates to sustainability of the prototype at the end. Certainly this evaluation is also informed by the documentation, it's not only the prototype. But there are, for example, team member success relates to teamwork quality, or for example, sustainability to a certain degree relates to team member success, or sustainability grades to team performance. Okay, so maybe you can play this. Great. Okay, so this is another doctoral thesis defended a couple of years back. And we used 5 sessions of the class, totally 10 hours of prototyping in the Fab Lab for computer vision study, which was analyzing the what they do in the Fab Lab with single camera. So basically, this one tries to classify: are they working alone? Are they communicating with the team? Are they communicating with the instructor? Or are they using the machine? And interestingly, well, computationally this is very demanding, but the final accuracy of the system is 87%, not very bad for a fully automatic system with single camera. But what happens is that we can see different patterns connected with their creativity actually in their work in the Fab Lab. So this is the computer vision system finding the different persons. Here the challenge is to not to misclassify the different persons, but it can quantify their interaction. For example, this is instructor and 2 students. There are 3 students working here. There is another person. Okay, this is one instructor on the back, and you can see that this how this is estimated. There are different tools, and these are plotted actually on the layout of the Fab Lab. Okay, maybe we can go to the next one. Yes. Oops. I didn't click. Okay. Yes. Okay. So what we found is okay. This is how this is classified. For example, the place in the Fab Lab, and this is, for example, the time. Darker blue is early in the time, and yellowish is in the later in the time. The pattern of a single person, for example. What we found here is that actually there are differences in terms of creativity. So basically their behavior, automatically classified behavior, shows different creativity at the end. So actually, kind of surprising is that more creative persons are more lone workers from this study. But this is example how this can be done in fairly automated computational method. And this is actually published in a very good journal, IEEE Transactions on Learning Technologies, a couple of years back. Okay, so this was the last one, and just to show you a few examples. That these studies are published in very good journals, and this is essential of this, I would say, is the growth of the students in the lab and their motivation. We are trying to work as a team in the lab, and we had a number of studies which are done also with outside collaborators. For example, this is done with outside collaborator, empathic responses in VR, published by AI Adam Journal. You have seen this from the last week's or 2 weeks ago, Amaresh's presentation. He said of AI Adam, but this is empathic responses in VR. This is in computers in human behavior, artificial humans. Umi's research was published in computational structural biotechnology. This is very hard to publish for conference. Design computing and cognition 2 years ago, and my last example, transactions of learning technologies. Okay, well, this was my last slide. Thank you.
Okay, thank you so much, Prof. Georgiev, for the lecture full of inspiration and thought-provoking presentation. And what I will carry from this lecture is your demonstration that design creativity research is not an isolated discipline. And the creativity can be studied empirically from build to build, and it speaks for cognitive science, AI, engineering, rehabilitation medicine to education policy. And now we have approximately 25 until 30 minutes for an open dialogue. Please, dear participant, maybe you can ask for a question to Prof. Georgiev. You can ask by scan the QR code, and then I will read the question, or maybe just raise your hand right now. Yeah, the first question is from, yeah.
Hello, Prof. My name is Hanifah. I'm the first year doctoral student under supervision of Pak Denny. You mentioned before that in the beginning you show us your experiment is mostly lab-based, using tools like EEG, VR, and also physiological measurement tools. But later you show us that you also study in a more natural context in the class and also in the makerspace. Yeah. So my question is about the lab experiment is relatively controllable to manage. Am I right, from? But I think the natural experiment in the natural context is sometimes most or have more challenge if I'm right. So what is the challenge to conduct the research in natural context, and also what methodological factor that we should consider to conduct research in natural context? Thank you.
Okay, so, well, definitely very fundamental question. This is pertinent for all design research. First of all, I think both polarities, I would say, but this is range, and we might be trying to move towards real world ecological validity thing. I think both have lies, and actually in the example with the brain activity, Neurocognition of Design Creativity, which I gave, unlike all previous studies which are very controlled thing, in this case, we are trying to break the things into smaller pieces and trying to replicate what happens in design education, because there is a certain point teachers sitting in front of the student and providing feedback, which is highly controlled. I didn't say it explicitly, but it's highly controlled. But then this also partially depends on the expertise of the teacher, because teacher cannot say nonsense things. There is a certain design on the machine, and then teacher, in some of the experiments it was me, but in some of the other experiments other teachers. But what we are trying to do here is to increase the actual practical-like situation. It's not the ideal, but at least the feedback to a certain degree is per this condition, so it's more like a real design studio, to say so. Like student has design, and the instructor provides feedback on his design. It might be critical, it might be appraisal, but all the things around this. And we're trying to replicate this. And I think the beauty of this is we are using very high-end equipment. I think most of the existing studies in design neurocognition are using relatively low-end equipment, which actually is a big challenge because they're losing a lot of real brain data because of various factors. For example, in EG there are a lot of issues with noise, or with connectivity between the electrodes and the system, or wireless systems. There are various challenges there. So we are kind of trying to cover both. Very challenging. These experiments, single person is 2.5 hours. It's very challenging, and sometimes can fail at the end for various reasons. But we're trying to keep the rigor thing yet, but also some practical relevance. And the way we are trying to do it is to introduce different sessions which try to replicate real design education. This is the example with neurocognition, which is the most controlled experiment type thing. You saw, especially in the last couple of slides, this is totally uncontrolled. We had a camera in the Fab Lab. I mean, they're free to do whatever they decide to do. What we do is later to analyze the video. It's not in the real time at the moment. So this is totally on the real world thing. So we're trying to cover all the things. There are different challenges. You can see that the real world thing, I mentioned 87%, but what is happening in the misclassified activities and so on. So there are different challenges. I think both are valid. I would like to give the example with the VR study, which is mixing totally quantitative part, but at the end is totally qualitative part. Interviews, semi-structured interview, mind mapping, and some very free conversation between the interviewer and the participant. And this actually leads to more findings. Actually, the interview is more insightful than actual empathy test, because empathy test does not say why. And they might show the difference, significant difference, but why? What happens? Why they think? And by the way, because this is actually 3-stage experiment, the same structure interview is informative, but at the end, the design rationale, I'm not sure if we can show it. Yeah. Design rationale, actually this is the most insightful, because at the very moment they begin to, the participants, they begin to rationalize, to understand why they're feeling empathy towards the condition. So it's like these 3 types of data, the last one is the most valuable, because in design terms, it shows the design rationale, how these ideas are rationalized towards the user group. So I'd say this is, I don't disregard any of these methods, that they should be used in certain joints, and there are a lot of challenges for sure. And certainly this brain activity is very challenging to do it properly, but we're trying to do it properly.
Mbak Deva, is it already answered the question? Yeah. Maybe another participant? Is there any? Oh, silakan. Yes. Committee, maybe you can distribute the microphone.
Thank you very much. My name is Georgi. I'm from the Department of Architecture, the neighbor of these buildings, the next buildings. I want to know if you have experience about architecture students. Is there any difference from architecture students? Because if you have experience experiment for architecture students, It is about the designs. What I want to know is about that. Is there any difference from maybe products designers or visual designers with the architecture student or architects as a designers? If you have experience, so I would like to know about that. The second question is about that. You know that why I have a questions about this one, because architecture is many kind of standard, many kind of rules if you want to design the buildings. So it is yeah, in your backgrounds that you have any experience about the design research. I want to know, is there any kind of something that rules to teach the students for architecture students, and this one is the preferred ones, because you already mentioned about that the student for the first years and maybe for the final years. Because in our departments, the architecture in the first years, we just deliver teaching terms about the standard. But is there the best way to teach them about the designs? Because some architecture schools, they teach very much art in the beginnings, but in IDP is have a difference. So which one is the best ones about how to teach the designs to the architecture students? Thank you.
Thank you. Well, first of all, I would love to experiment with architecture students, but none of this is done with architecture students. Maybe we should try to do something about this. And also, I would love to see the difference between early unexperienced designers, first year or last year. Certainly, well, I cannot project this to architecture reliably, but at least some of the things on general level can be used as teaching practices, teaching approaches, and that's a kind of reason we're tackling the abstraction. Well, certainly abstraction in context of design and education might differ, especially towards the in different disciplines. But one takeaway here might be that we might improve, let's say, training in relation to creativity by training them to think in more abstract ways, at least in certain moments. Maybe this is related to divergence or novelty, or some of these studies show this. But at least the evidence here shows that abstract thinking probably is helping in improving the results. So anything which tackles abstraction in a more explicit way in teaching might be helpful. But this might be very different approaches, because we are just in the beginning. We're tackling abstraction, but there were three other aspects which were still yet to be investigated. I'm particularly interested in polysemy, which is quality of having multiple meanings. So it's more on meaning side. So this is, well, more in line with the associative concept networks we were trying to do with Danny. Yes, some of these things might be difficult to translate into instructional recommendations, but it might be on general level. So, for example, certain abstraction techniques to be taught to students, because this might lead to higher novelty, for example. Yeah. Or surprise. We saw this novelty and surprise. Actually, surprise might be fairly interesting feature of design. Yeah. If that's I hope this kind of answers the question.
Yeah. Before we move to another participant, Mr. Dedi will deliver some explanation.
I will speak Indonesian language. Ya. Jadi saya mau cerita dulu karena tadi pertanyaan Mas Doni itu sebenarnya dia sudah melakukan riset dengan Hernan Kasakinto. Ya. Hernan Kasakin is from the Technion Israel,
Yes.
in the School of Architecture.
Yes. Yes.
So the participants are from the, I think, the design studio for the experiment. Is it?
No, none of this experiment is with design studio, but
Yeah, the paper that you work with Hernan Kasakin.
this one is in industrial design.
Industrial design. Okay.
Architecture.
Alright. Ya, anyway, saya mau cerita bahwa Georgi dan saya dulu sekolah di JAIST itu kita punya 3 fakultas atau sekolah ya. Fakultas sekolah namanya di JAIST itu satu Information Science, Material Science, dan kami di Knowledge Science. Nah, Knowledge Science itu dilihatnya ada yang tentang Service Science, ada yang kita di design cognition lah kurang lebih ya. Jadi tentang menstudi proses berpikir dalam viewpoint design. Can be apa aja desainnya kan? Seni juga masuk juga. Pokoknya proses kreatif dan proses berpikir. Nah, proses berpikir kan berarti kita mau exploring, mau uncovering, ada hambatan, ada stimulation, ya kan? Terus ada apa namanya? Hambatan, terus apalagi dia contekan dulu ya. Terus ya all related with the mental spaces. Jadi semua yang terjadi di kepala dan embodied gitu ya. Jadi kira-kira itu tuh. Jadi topiknya apapun, bukan topiknya, partisipannya atau research theme atau topiknya di design architecture itu bisa-bisa saja gitu ya. Kalau supervisor kami, mahasiswa juga banyak yang dari arsitektur sebenarnya. Papernya saya bisa tunjukin nanti itu ya. Nah terus berikutnya, yang menarik nih, mungkin terkait sama yang riset sebelumnya. I'm recalling your previous research that forecasting creativity, right? You have that. Jadi Georgi itu punya paper bagus ya di Jurnal Top tentang meramalkan kreativitas. Yang saya baca cepat itu waktu dulu tuh begini. Karena kita bisa meramalkan kreativitas, maka mahasiswa tingkat 1 di kuliah studio, kalau di minggu pertama udah jelek, udah gak usah lanjut deh. Udah tahu hasilnya pasti jelek desainnya tuh. Forecasting creativity di samplingnya itu mahasiswa di desain studio. Forecasting creativity. I think that one of your paper that you share at the JAIST World Conference, investigating the creativity for the design studio course.
Yes. Okay, maybe.
Ya kan gila ya. Jadi mahasiswa arsitektur kalau udah semester studio 1 misalnya di minggu pertama, nah ini nggak oke, nggak usah lanjut lah, udah tahu pasti D lah. Gitu. Tapi itu ekstrim saya ya yang menyimpulkan gitu. Oke, ini lanjut lagi nih terakhir. Jadi sebenarnya yang menarik dari presentasi Georgi adalah kita itu diajarkan waktu S3 jadi awal-awalnya itu tentang research protokol. Karena banyak riset itu kan biasanya kita ngumpulin data verbal ya. Tapi terus verbal begitu saja disimpulkan secara kualitatif. Nah, verbal ini sama kita diolah dengan software gitu. Dengan software network analysis dan macam-macam. Jadi sama wawancara, cuma kita wawancaranya bukan kayak retrospektif gitu ya. Bukan orang yang sudah kita selalu biasanya wawancara ketika dia sedang melakukan desain itu paling sering begitu. Jadi concurrent gitu. Supaya kita bisa nangkap yang lebih sejati dari situ. Baru kita olah dengan software dan pemodelan gitu. Jadi kita belajar tentang research protocol, analysis protocol, dan tadi Georgi juga nyebutin tentang abstract thinking dan concrete thinking ya, to compare. Nah itu kan menarik ya. Kita mungkin abstract thinking itu ya berarti yang berpikirnya waktu kita masih early ideation gitu, sampai yang udah mulai masuk ke design development ya. Concrete thinking, nah mengcompare itu dengan software, dengan metode, dengan tools, dengan statistik itu menarik sekali. Ya, itu pretty much I was explaining at the initial when we start our PhD program at JAIST, we were exposed with the expert in the cognitive scientists. So we encounter a new things, learning how to capture and analyze the thought process. That is the way we usually learn about the study of the thought process.
Yes.
Please continue.
Well, maybe you were referring to this study from a few years back, well, 2019. No, this is 21 of officer. Okay, so what is not apparent here immediately, this is actually based on the industrial design, and half of these students are doing sitting device, chair. Okay, and actually you can see the form, linears, so from the conversation here. So, this is from US University. 11 students and totally 36-7 sessions over the course of a semester. Their conversation with the teacher. I mean, to say some critic, design studio critic. And this is the analysis of their 36 or so conversations. And this was various aspects built on the semantic network from the conversations. And I mentioned this, but this is actually the variability of the parameters of the semantic network over the time. And all conversations are taken together, averaged to 0 to 1. So here there was a clear difference between successful and unsuccessful idea. Discussion between successful and successful and creative, not creative ideas was very different. And this is real world data. Never. This is not experimental. Just this is video from US University design study, industrial design, and I think 6 of them were doing chairs, and the other 5 were doing laundry device. It's not a washing machine, but a laundry helping device. That's assisting device. So industrial design. So these were statistically significant findings on the basis of the conversations, and we are trying to feed this back to experimental setups, either purely rigorous experiments or more natural settings, as we saw. I hope this is clear. There was a question.
Another question maybe from Master.
Yes.
Thank you so much, Professor, for the opportunity. Thank you, Reni, also. I would like to ask Professor, how do cognitive stimulation and an individual capacity to absorb and process information influence each other? Additionally, what readiness factors are necessary for extreme stimuli, including AI-generated inputs, to produce optimal cognitive and creative outcomes? Thank you.
Well, this is definitely fundamental question, and probably subject of many studies. And certainly, I think tools, especially visual ones, nowadays have huge influence nowadays. Well, I particularly find some of the images from Midjourney very visually overwhelming, even in terms of the design. Well, this is what we are trying to at least partially understand here. The example from the master thesis was like we are trying to control the visual qualities of the stimuli, in order to see how this affects, in this case, it's brain activity. This actually is their experiment now. Actually, these are master students in design in Italy. The student now, she's in Italy doing experiment in Politecnico di Milano with master students in design there, engineering design. But we're trying to see how the visual stimuli. We hope this is fairly controlled, but then the experiment is more closer to pen and paper designing, we all know. And we are using EEG, but there is not that strict because it's wearable EEG, a little bit better, more ecologically valid to real design. But EEG is always challenging because it's susceptible to some noise. So we're trying to understand the cognition there. Certainly, some of these premises are very basic, at least in neurocognition. So, like this means more activation is higher activity, or higher current is more activation, or certain things. So it's basically comparative. So it's not absolute. We don't know with absolute what happens there, but we can compare this to pure neuroscience studies, which say, for example, this place is responsible for this kind of thing, like speech processing, I don't know, visual imagery and such things. And we can try to draw conclusions there. Certainly neuroscience is much more rigorous than what we are doing, and that's, I think, the biggest challenge in design. How be, like the first question we had, how to be real world, but then to be scientifically rigorous. Yeah, that's the challenge, yeah. But in this case, I guess that the best current strategy is the best one is we can try to find some certain things in this way and try to compare to, for example, neuroscience and see things. By the way, there are some recent studies which use brain stimulation, like transcranial magnetic stimulation of brain towards creativity, and they seem kind of successful. That means stimulating particular areas of the brain might lead to higher creativity, which is kind of, I don't know, scary, but yeah, still. This is kind of verification that the other finding has been right, that higher activity in certain place leads to higher creativity or something, yeah, like this. Yeah. No, it's...
Okay, thank you so much, and we shall move to the sliding question. This one, Prof. The first one question is from Zidan, but Zidan gave me a signal that you want to ask directly, right? Okay.
Thank you, Professor. I just want to clarify the question I sent to the side too. So, given your the first question, how can given your number of publications on VR technology and your research into design creativity as presented on this slide, you have documented how immersive environments alter human experience, and building directly upon your work and your research regarding design frameworks. I would like to ask a question concerning the long-term psychological outcomes of these virtual spaces. So my question is, how can creativity research methodology or methods isolate the lasting subjective well-being benefits such as cognitive life satisfaction, the presence of positive emotions, and the reduction of negative emotions of VR designed from a temporary tech novelty effect? Because our primary methodological challenge here is how can a research framework successfully give actual independent psychological benefits produced by the design itself and separate the temporary cognitive excitement of using VR new technologies. That's my question. And I almost forgot to introduce myself. My name is Zidan and I'm from Architecture Mastery Programs.
Thank you. First of all, there were a few different aspects which I presented. For sure, cultural differences I don't think can be altered by 10 minutes. In the longer term, they cannot be altered by 10 minutes experience in VR. At least in just shorter term, it's probably related to we didn't test this, but my hypothesis would be that this is very short effect in terms of cultural difference, for sure. In regard to empathy, it's a little bit longer term because we had a study, 3 months difference between the first question, the area of the empathy, and then follow-up question is 3 months later towards the same situation. This is not published yet. It's not on the slides, but at least 3 months later, empathy towards certain condition in the result of 15 minutes VR experience is still higher. So there are empathic effects in terms of this kind of time scale, yes. I don't have proof that it's beyond these 3 months, for example, for empathy. But it might be matter of repeated exposure. So if it's something experienced, this kind of immersive experiences, if they are repeated over course of a year, several of these, might have much longer effect, I think. So what we saw here typically is 10 to 15 minutes experience, and we are testing it immediately after that. That means in matter of 1 hour experiment or something like this. So the only evidence is that this is short-term effect, and most of these participants are not very much experienced with VR. If somebody uses VR on the everyday basis, there might be more subtle effects. This is hypothesis, totally hypothesis. But I would expect the effects to be more subtle if somebody is a heavy user of VR, let's say gaming or something like this. Because, well, hypothesis, just hypothesis here. So we don't know this effect, but at least current understanding is that the cultural differences is a temporary effect, definitely. Empathy is longer term, but keep in mind the empathy is at least 2 major categories. One is trait, empathy, which is not changing easily because it's something formed early in life. State empathy is more, well, temporal thing. So it might be influenced by something as simple as looking at some video. There might be some temporal effect on empathy towards something seen in a video. But definitely this is a very big question, and there is no clear answer at the moment, at least. But keep in mind, we are using the VR technology in the sense of experimental tool to understand human. It's not necessarily well, it can be used as a practical tool. So, for example, imagine you have multicultural team in industry, and you have the VR experience, 15 minutes something, and team performs differently. Well, this might be a very practical tool for international companies that are having very diverse teams, especially over long distances. Might be. Yeah. In that sense, it's a fairly affordable tool because you can have it in very different places. Yeah. But this is not tested, at least I don't have a test of this in real company context. Yeah.
Resident, this already answered your question. Okay, maybe we can pick two last question, Prof. The first one is from Mr. Faikar. How do you generate your research ideas, especially for empathetic experiences and rehabilitation field, and also how to design methodologies for such research?
Okay, so I would say at least a few different pathways. For me, very revealing has been contact with patients. I mean, a day in therapy clinic, it's a lot of impressions. Certainly, many things can be think, and so some of them are overwhelming impressions because you might see certain conditions which are very, very challenging. But this definitely helps ideas. Other way to the research ideas, I always find long discussions with students, and it should be a kind of free, not restricted by hierarchy or something. So I'm always trying to do this. Some of these studies actually in VR are generated by bachelor students. There are teams of 2 or 3 bachelor students, and we sit multiple times. We sometimes disregard many ideas. Well, new idea, oh, this is good one, but go, new idea, how to go with this study. And they have been proven successful. And by the way, the essential tremor study, personal motivation, one of the students had this condition. I mean, it's not severe, but it's a little bit, yes. So, personal motivation, we went with this, and actually personal experiences were very informative for designing the actual experience. So I think these two pathways have been very instrumental in the rehabilitation field.
I think we have the last question, Prof. Are some individuals truly uncreative, or are there factors that make them seem so? How can I help enhance creativity?
Well, I don't believe in non-creative. I think everybody can be creative. It depends on many things.
And it can be trained.
It can be trained. Well, I must admit one thing. When I was a young teacher, I started teaching in '97. My first full class was '99. Initially, because this was visual communication design, initially I was thinking talent is, in design field, talent is 2/3 everything. It's not. It's not. It's trainable. I think 2/3 is trainable. 1/3 is talent. No.
Talent is 1/3.
Maybe even less. 1/4. The remaining is trainable, I think. And it's matter to find your path. People are different. Somebody might think it's not uncreative. Well, this is. I didn't know this word actually, uncreative, but yeah, okay. I don't think they're uncreative people. Everybody can be creative as long as this is trained or cultivated in certain way. Yeah.
Many papers mention about it.
Yes. Yeah. And people are differently creative, actually. It's not one thing.
It is our superpower.
Yes. Yes. Okay, another question?
Yeah.
8 minutes ago? No?
And the last one is not a question, I think. It's about your paper before, about personal happiness, or the crucial elements of personal development for citizens to especially consider to their activities and interaction with student and their supervisor. Is it Mr. Dennis already sent me one of your paper? Maybe you can introduce or explain your special paper.
This So this paper, the one that I mentioned, to predicting ideas, whether the success of ID generation. Jadi kalau tadi saya sambil melebih-lebihkan kan ya, oh kalau yang nggak kreatif udah aja nggak usah lanjut kuliahnya gitu, itu biar seru kan ceritanya. Tapi the ideas of the paper is we can enhance creativity and we can measure whether the ideas is good or bad. But Georgi will explain very short about this, right?
Well, this is the original paper we had. This is, at the time, it was very hard work. It's more than a year of calculations on this real data from Purdue University, US, industrial design students. And it took a lot of time to refine the method, but basically what it says is that we can predict the correctivity of the ideas halfway throughout the process. We can, by the features of the semantic network, 4 parameters, metrics of the semantic network, can predict computationally where this is going in terms of success and creativity. Yeah. Well, might be very, I don't know, challenging as concept, but actually it's what the data shows. Yeah, and we don't have any control on the data. We just had the data. Certainly, this is far from perfect because it's one case of industrial design. Students.
It was
students. Students, yes. Student participants. Mostly it's critic by the instructor to the one student, but sometimes the instructor asks other students to critique this idea or something like this. Yeah. So it's design studio critic in that sense.
Visual Grad. But I remember when you discuss about this during our meetings at the JAIST World Conference. The other, maybe the next, the simple, that grab, that visual grab. Yeah,
yes.
the gede ini maksudnya.
Okay, well,
Yeah, this one.
later on, okay.
Very simple line explaining the potentiality of ID generation that considerably good or bad.
You can go later, later figure. Later. Yeah. Yes, this is also. Okay, yes, okay. Yeah. Abstraction is relatively weak, but it's easily computable and easily translatable to instruction. Polysemy, huge difference between the trends of successful and unsuccessful ideas. Semantic similarity, huge difference. Also this one, information content of the. Well, I would say that our next target, at least computationally, will be information content of the conversations. We'll see. But yeah, this is difference between successful and unsuccessful. Paper also talks about creativity, difference in creativity of the ideas. But this is a fairly objective thing because it's replicable on other data in the same way. Yeah. As computation.
Polysemy tahu ya? Jadi sebuah kata mengandung banyak makna.
The quality of having multiple meanings.
So jadi kalau kita ngomong, one word can be associated with some other words associated.
Yes. Well, certainly language dependent, but I would not try polysemy with translation. It should be in the original language because it's language dependent. This is more objective, abstraction but polysemy in English certain words might have up to 40 meanings, like I don't know. I don't know. It's bank is the classical example of multiple meanings. River bank and money bank. It's yeah, two very different meanings. Yeah. Okay. Well.
It's 12 already.
Yes.
I think we. Jadi saya MC-nya.
I think the time is already flown, and we have reached our end of this session. And Professor Georgiev, on behalf of the Faculty of Art and Design, and also everyone in here, thank you so much. And let's give Professor Georgiev once. And yeah, before we end this session, we should have a photo, right? So every one of you, please gather in front of the photo.